goal is to find the rules through computer modeling that allow us to conceive the new generation of materials in applications that range from rocketry to airplanes, cars, armor. My name is Pedro Rivera. I'm a professor in the engineering department at Lancaster University. What I work is in laser powder bed fusion, which is powders, metallic powders that through a laser are printed in layers, and layer by layer a three-dimensional product is constructed. That's why it's also called 3D printing. There's a large range of products that could be 3D printed, from aerospace turbine blades, for instance, to components for tools. Additive manufacturing is unique in the capacity to engineer or to structure the material layer by layer. Some of these layers are less thick than a hair. For instance, in the case of the turbine blades, one existing application is such that the blade contains canals that will allow to cool down the engine. The unique aspect of 3D printing is the capacity to achieve shapes that can be programmed on a computer, and then they can be 3D printed in a different location. Additive manufacturing offers a great ability to locally produce the entire component, from the production of the material to the final component, because we only need to produce powders that are then 3D printed and the component comes out. When one produces a wrought component, a lot of energy in shaping and reshaping the material is required. 3D printed from the start will give you the shape that you want, and that shape will be very close to the final one. So a lot of material waste and energy in those operations related to shaping the product will be avoided. Carbon emissions will be reduced dramatically because the ability to produce a part from a powder implies that it's 3D printed and there's literally very little waste of material. Some of these powders can be recycled and they can be used to produce a new part. 3D printing offers two unique features. One of them is the fact that the topology, the shape of the product, can be very complex. And the second is that the laser allows you to control very precisely the properties of the materials on a layer by layer, which again cannot be achieved with the traditional technologies. In the case of armor, for instance, it is possible to produce layer by layer properties in the material such that when a bullet comes into the armor, it dissipates energy in a different way. 3D printing will allow to produce, say, vest or waistcoat that cannot be penetrated by bullets, that is much lighter because it contains a lattice structure. And those beams that connect the lattice are the ones that can react actively and with different properties and dissipating energy as the bullet penetrates the body armor. The principles that we can learn from it are very interesting because you can even go to other applications. For instance, golf clubs, where you need a very light club but that is very strong at the end so that there's no deformation when the golf ball is hit. Well, a very futuristic approach that if we understand what are the minerals that we have on the crust of a new planet, for instance Mars, and we have the technology to extract and refine those metals, to produce powders with them, and we have the right printers in situ on the planet, then we will be able to do everything. We will be able to produce the new components that will satisfy the needs of a future colony on planet. So the Royal Academy of Engineering has been essential in providing the resources for us to focus and concentrate on the pure research so that this is exploitable and can make an impact. The best inventions are always the ones that come from fundamental principles. If we understand the fundamental principles that control these materials, then we'll be able to engineer properties that will lead to totally new applications.